the methane.
Methane, he's talking about methane C1, yes. C1H4.
So what do you do with that?
We can I answer? We can, there's several things you can do. I mean, right now, methane is, natural gas is 95% methane, 5% other things.
Right.
The fact that we have a clean methane source will find a value or a market in the high-tech industry. So we could contain it and sell it for much more money than natural gas component. That's really the benefit of this. You know, in the worst case scenario, you just basically dilute it and sell it back into a pipeline at 1,000 BTU quality, which is natural gas quality.
Right.
What's the difference in process between the shell and the sands?
I'll tell you in a second.
Okay.
I have to go back to that. Let's just finish one thing.
Yeah.
One of the areas here that is very interesting in our process is the flexibility. Residency and temperature. Residency time is the time that the gases stay in the process, in the cracking process. Temperature is something you can modify as well. You can have a process with much higher temperature, and one of the key areas in our R&D is to find the sweet spot in the temperature. But if you increase that, what actually happens is that you will create a much greater stream of light crude and a much greater stream of gaseous products as well. So you should expect a much greater output of hydrogen and a much greater output of light crude within the liquid section. Because what you see over there really is a continuum. If you think coal is in one end and you see natural gas is on the other end, all these products are in between in terms of molecular weight. And what we're doing here is modifying the molecular weight of the actual end product. So our process will have that flexibility. To go back to your question, I have to just show you one thing here, which is basically, this is the structure of oil shale. It's rock, it's heavy. Oil sands is sludgy. So if you drill here, your integrity will collapse. But the way we have come up with oil sand solution is by having a drill casing process that happens at the same time. So you maintain the structure by keeping the case. So effectively, in the sand process, you won't have an effluent pipe stopping here, but you have the effluent pipe all the way to the end. And the difference goes in the middle. What happens here is that the casing material is designed in a way that allows the heat to get out and not the sand to come in. And the product, because it's gaseous, has the same attribute as the gas coming out, so it has a pass-through possibility and allows for the venturi effect to occur when you actually suck the air out in a negative pressure system environment. So it basically has a material science component here that is very interesting as an application for oil sand.
Where is this process being used?
That's a good question. Let me show you. We are a startup energy company. This is a process that we have defined, developed. We have proven the basis of the functioning. We have proven that it works. The gasification process has been proven in numerous places. The permeability when you apply heat to the rock has been demonstrated as well. What we're intending to do is to take our resources to develop a full production field experiment and prove the technology in a way that we can record all the data coming from production and create a simulation for future processes. And then we have actually a three-step program where we intend to have a first proof of concept, then a second phase which would be a commercial prototype, and then the third phase would be an actual commercial plant in that order. And as a matter of fact, we're right now in the middle of looking for financing to develop the proof of concept.
Have you modeled the impact of groundwater on the heating process?
Well, yes, that's part of the R&D intent in the first proof of concept. And I have a lot of more slides, except that I don't have them in this presentation, so I'll be happy to follow up with that. But let me just tell you one thing that is important to take home from here. This is the current curve of costs of resources in the world. And what you see here, from here to the left, is conventional oil. This is how much it costs to produce to an OPEC country. Anywhere between $6 or so to about $15 or $25 or something like that. And other conventional oil that may or may not come from OPEC is below a $40 per barrel kind of a cost structure. Anything above that, and please, this is very interesting, anything above that is the future. This is going to end pretty quick, because the peak oil is already, we're in the second, we're over the hill, if you will, like myself, because I just turned 40, and my wife gave me a party over the hill, so now it's over the hill. So from here on, every resource that you're going to extract from the ground is going to cost a lot of money. And oil shale currently has an estimated price for current surface retorting processes that go all the way to the $100 mark in terms of cost.
Are you saying that right now to get oil out of the tar sands in Alberta it costs $100 a barrel?
Yeah, well, no. What I'm saying is that there's a range. There is a range that goes between about 50-ish to about 110. That's correct. So some processes are as expensive as $110 per barrel, and I think Alberta sands are around 65. That's their our estimate of what the cost estimates are. But our price range, and again, I have a lot of analysis to validate this, is way below a $40 per barrel. This is the range at which we expect to be produced.
Do you have a customer signed up to be your guinea pig?
Define a customer?
Customer would be apparently a first customer who says, I will put this on my property.
Well, we have land, yes. We have land in Wyoming and in Colorado where we're ready to put our machinery on.
Is that federal land?
No, we're staying away from that. Simply because it's easier for us to get the ball rolling in a much faster way. So we have secured land in Wyoming and in Colorado for that purpose. But if we are able to produce with this price curve, we will be displacing and using oil shale resources with our technology in the United States. That is the road to energy independence. If we're able to do that and produce enough critical mass in the United States with oil shale at the cost structure, we will be transforming the United States of America's economy. And I think, you know, the kind of investment that is required for doing this, just to displace imports. Right now, the trade balance is $700 billion deficit, and 500 of that is oil imports. If we, 6 million is half of that. This is what we're taking currently from OPEC and Russia and other nations. This is the 6 million that was at the beginning. The multiplication effect of this is enormous for the United States of America. And you know, that is what I call about sustainability. That's what I talk about when I say take a resource, think of a different approach, and create something that is sustainable, where everybody can, you know, make money with the wealth creation multiplier effect.